Hi, I'm Chris Billiar, Professor of Biomedical Engineering at Worcester Polytechnic Institute, and this video is to explain and show how to run a uniaxial tensile test using an Instron 5544 running Bluehill 2 software. First thing to do is log in. And I'm an admin, so I have this administrator button running, but if you log in as a regular user, you won't see some of those buttons. You need to select, first thing you need to do actually is turn on the machine, and then you log into Bluehill. After you turn on the machine, let it adjust for about 30 seconds. Then you choose a test, and I'm going to choose a Bluehill regular tensile test, such as the test example. And we can save that later. And I'll be testing a piece of leather. And you can see here there's information to type in already. It's a rectangular geometry. You can put the thickness, length, and description in here, but I want to look at the method in detail for how what the test is going to be running. So I selected a tensile test, and there'll be another video on how to select other kinds of tests. In the method, you can choose the type of units, the sample, the basic layout of the screen with graphs and with sample information. You can do different kinds of advanced layouts. For the specimen, you can say whether it's rectangular, circular, irregular shape, and you can type in the dimensions. Those are very useful from going from force displacement to stress and strain. You can type in other kinds of units, text and number inputs, and choice inputs. But the more important thing next is to go to control. And this is how you're actually running the test. There can be various kinds of pre-tests, such as preloading, auto-balancing, and pre-cycling, which will be the focus of another video also. I want to keep this one short. The test itself can be run under different types of control: load control, strain control, extension. Here we're going to run at 10 millimeters per minute rate, and that can be chosen through this method, or in the test the user can select it if we've given them that option. Really important is when is the test going to end, and for failure, a standard ending is rate of load, or changes of 40% of the load that you're at. But another one would be to make sure it doesn't hit some kind of limit as like extension, but I always like to put in a load control. So that's actually up a little bit here. So load control, and this machine can go to 2,000 newtons. So I'm going to put in 1,900 newtons, and then you have to hit enter, select something else, because I don't want it to go near the limit of the load cell. And I'm going to ask it to stop and then return automatically, or you could also have it just stop or return automatically, or protect the sample by pulling off of it a little bit. But stop and return I'll do this time. It's important to take data, and in this case it's set to manually take data every 50 milliseconds. It's probably more data than I need, so I'm going to have it do every 100 milliseconds. But you could also have it do it per other criteria, such as every 2.5 newtons, and that'll give you data when the load is changing fast, but the time is not going as quickly. So I could add that as another criteria. You have to define how you're going to calculate strain, and you could use an extensometer or the internal extension channel, and I'm going to use extension, and then it'll use the extension that's measured by the device, divide by the initial length, and calculate the strain. And you can have it give various alerts. I'm not going to go into that now. Then calculations, which again will be a subject of a whole nother video. There are lots of different calculations you can do at at the peak values, when it determines it breaks, such as the force at break, which may be different than the force at the peak value because of differences in true strain versus, or true stress versus engineering stress, or modulus. And you can calculate the modulus, and you have to select these and bring them over into the selected calculations bin, or they won't be showing up in your results, which brings us to the next. And so in your results, you can have it put in a results file the maximum load, if you've chosen in the calculations section that you want at the maximum, or these won't even show up if you take them away from the calculations here and you took maximum load away, putting over there, then in the results it won't even give you maximum load. But if we go back here and put in at break or absolute peak, you can get in the results, you can then put maximum load in now, because at the absolute peak you can have other inputs, other calculations come out, such as at the maximum extension, what is the load, and you can have it calculate that as well. There's other kinds of results that you can have a second table of results, and you can do statistics on those results and such, and that's again the topic of another video. You can have it graph load versus extension, or any other, or stress and strain, or other types of variables, load and extension versus time in this section, and you can change what is the x-axis, such as extension, and I'll change this, actually the x-axis, I'll change that to time, so you can see time changing, and then the y data, we have here load versus time in channel 1, but I would like a second axis, so in the type I'm going to have a second axis for extension also, so a double y-axis, and now I go to y data down here, and it'll ask me for the second axis. I would like extension also plotted, and this will use automatic scaling, or you can do manual scaling. And there's one of them is red, and one is dark red, which I think isn't that great, so I'm going to make one of them blue, and this will be the subject of another video. But let's see, our y2 axis, plot 2, solid color. Instead of being dark red, I'll make it blue. And now you can have two different colors. You could have a separate graph to do stress and strain, but as I mentioned earlier, very quickly, when I go under general here and I look at what is my layout, I actually have the layout chosen under basic layout here to be a single graph and calculations. If I want both of those graphs, I have to go here under advanced layout, and then my graph 2 will show up. And my graph 2 here is giving me load and extension. I can change that to be my stress and strain. It'll calculate it for me, tensile stress. And my x data, I can have be my strain, tensile strain. Here it's in millimeters per minute. Maybe I want to do it in percentage. Now all that data is just being stored in a file, Instron file. I would like it stored in actually an Excel file or a comma delimited file so that I can analyze it in other programs. Here, right now, it's going to give, in terms of raw data, time, extension, and load. I'd like to also add in strain. So tensile strain, and you can do it in millimeters per millit or other units. And I'd like also tensile stress. So here it is. And I can have those plotted out also, and you can change the units and the number of decimal places. And it'll look something like this. Too many significant figures probably, especially in newtons, since this has a resolution more on the order of 2.5 newtons. You don't need all these extra non-significant digits, but you can leave them if you like. and it's important to tell it where you want this to be saved. So here it's going to produce a series of reports. One of them will be this format here, a PDF format. You can have it print graphs automatically, and you can select an output path. So you can say, I want it to go to my desktop, or under my documents, under there, I can have it saved there. I want it to export results. That was just a PDF that has pictures of the graphs, but here export results, you can have it in common delimited file. That's what I'll suggest, and you can have it select different information for the results table. I would go in and select whatever you want, and then really important is the raw data, that time versus the force, displacement, strain data, and it can come in a raw, but I'm going to suggest a CSV file. And what you select here for results are just results that will be at the top of the file in a header, not the actual raw data. So I'm not going to put anything in it. Well, maybe I'll put in there the dimensions of my sample, so my length that I want to put in there, my thickness, and my width, so I know what was how I was testing it, and I'll have that information in the file. And then there's a series of test prompts where it's going to ask me different information. So now I've gone through basically the program, and now I want to go back to the test and run a test. So my company, I can type in here. That's our department. It is a rectangular sample I'm going to do of leather. I have to move the crossheads down to load the sample. But before I load the sample, and after I've gotten my grips mantled or loaded on there and tightened on, I need to zero the load. To do that, I can go up to this symbol here, and this tells me what's being presented in these files here, and I'm going to tell it I want tensile strain shown, and I'm going to have it in percentage, and then I have extension and load, and maybe I'll have tensile stress being indicated, tensile stress being indicated there also, and I can have different numbers of live displays. And I want to change these keys here. I want to have key 1 balancing load and key 2 resetting gauge length. Then I want to come over here to the top, and I want to set, once I've balanced my load, so I have nothing on my load cell, balance the load. I don't need to reset the gauge length. I haven't put anything in it yet. I want to come over here and I want to set my limits. And I'm going to set them, it says 2100, but I'm going to set them at 2000 because that's the limits of the actual device load cell is supposed to be. And it'll stop it, and then I want to enable those when I get to those limits, so I don't go over those limits. And that's indicated up here. The green up in the corner here indicates that it's under displacement control right now, which is going to be for this whole test. Okay, so now I need to load my sample. For that, you can't see this, but I'll move my mechanical steps. You'll notice up here that the extension is moving. I don't have anything loaded in there, so load's not changing, but my extension is moving because I'm moving the grips down. I set my mechanical stop very carefully so my grips won't hit each other once I know the distance between them. Tighten my sample in place, and now you notice I have an extension of -91. That's not a real extension. I have a little bit of a negative load on there. I don't rebalance the load. I move up a little to put a small preload on the sample. There I'm starting with about 5 newtons, and again, this is a piece of leather I'm testing. I reset the gauge length because now this is what I'm defining as 0, and you'll notice tensile strain goes to 0. And now if I want this to calculate my stress and strain for me, I need to put in its thickness, width, and length. And there are videos that show how to do this also posted on YouTube. And so I'll measure the thickness, width, and length. 1.3 millimeters by 12.3 millimeters. And then the length between the grips. 34 millimeters. And it's leather. Okay, so now I have put my sample in. I've balanced the load before I put my sample in. I've set my stops so there's no way, mechanical stops and electrical stops, so there's no way my grips will hit each other and break something. I have limits set in the program also. I've set in the manual, in the method part, I've set it to 10 millimeters per minute. I could also add that to this area, what the rate is, under test prompts. I will go into that in a different video also. I could have it pre-cycle and automatically reset the gauge length for me in the program, but I didn't do that in here. So now I am ready for test, although I need to put on the safety, and there's a separate video to show you how to put the safety shield on. And I have the emergency stop available if there's any problem. So now I'm safe for myself and I'm safe for the machine. And now I hit next to run sample. Specimen label 1. Here's my rate prompt. It's the width and thickness and length are still there in this test. I've installed everything in the machine and I put my safety on, and now it's starting to test. If I want to see the load and time better, because this is quite compressed, I use this button right here, and now it's showing me my load versus time as this piece of leather is being stretched. If I want to look at stress strain curve in real time, I push that button, and here's my stress strain in megapascals and tensile strain. Go back to my graph here. And this may take a little while. I'm not testing it too fast. Actually, you know what? Since this is taking so long, I'm going to stop this test. Now I can return. I can hit OK to return, and it brings it back down. Now it's stretched out during this test, but it'll give me calculations up in here, and I can look through those, and I can make that larger to see them. And I can close that back down, and then I can test it. And I want to test it as if it's another sample, but actually I just stretched out the first sample. But I want to go 10 times as fast because I was too bored going too slowly. Still have my safety, everything's set. I'm back at extension of 0. My load's around 0. I'm not going to preload it this time. I will show you how it looks when you've pre-stretched something. And again, my safeties are all still on, and I'll run this really fast this time. And you'll see, because there's pre-stretched, there's that long area there. If I look at this, the second sample is in dark red, and it just broke because I went much faster. So this was my first cycle, and then I brought it back, and it had stretched out, so it was flat here, and I brought it up. It's automatically calculated my Young's modulus for me, and then the sample broke here, and this is the maximum load, and this is the maximum strain on it. When I hit OK, it'll return, so I make sure nobody's hands are in there, and it returns. Again, now if I look at these two samples, they were actually the same sample, but I have my information here. This is not real loaded break because I stopped the test manually, but this is the true loaded break, and it's calculated my modulus of the leather for me and the load at the maximum tensile extension, whatever I've asked it to plot for me. Now this is important for, and these are the statistics, this is important for saving the data. You have to finish the sample right here if you want it to save the data into the raw data format. So I hit finish, and then it can say, do you want to keep doing some more? I say no, finish the sample, and I can save the document. Under my documents here. Do I want to start another sample? No. But the test method has been changed. I made changes using this method here. I want to save what that is. And instead of tensile test method, I don't want to put it back in Bluehill. I want to again put it where I'm saving my documents. Save it as something else in my files. And I can go back and use that again the next time. So there'll be separate videos for showing you how to go access that data and open it in Excel or other files or MATLAB, and there will be other videos to show you how to change the test prompts for how you're telling the user what information to add. So that's the end of our video on overview of how to run a test using Bluehill 2 on the Instron 5544.